geologic time scale to scale. Now, you might not necessarily know what this means. A geologic time scale is essentially it's a chart that showcases and breaks down all of Earth's history. So Earth's formation all the way up to the present. So you might see in the form of like a timeline or a bunch of rock layers stacked on top of each other with different names. It basically is just breaking down what kinds of periods Earth has gone through. It might show up some of the animals at that time. What we're going to be doing in this program is we're going to be doing a very brief 30-minute tour through all 4.6 billion years of Earth's history. So it's going to be very brief. There's going to be a lot of stuff to cover. So I'll do my best to get through everything. So, oh boy, there's a lot to talk about. And as we're going through, we're going to be building a 2-scale model of geologic time, a 2-scale timeline of Earth's history out on the stage. And as we do so, we're going to be interacting with some of these prehistoric creatures and putting them in the times in which they belong. So if you like to get your hands on some stuff, you can do a little audience participation. That'd be much appreciated. That means you get to play with some of these fun prehistoric critters as we go through. So the general scale we're going to be using is 1 centimeter equals 1 million years. And bear with me because I forgot a piece of the time scale. There we go. So we're going to be starting at the present and working our way backwards. So I figured we might as well jump in and get started. We are going to begin at the current time where we are currently now. We live in the Quaternary period on our geologic time scale. These are a little slab. It started 2.6 million years ago and is still happening today. Because it is 2.6 million years long so far, it is 2.6 centimeters on our time scale here. So let's plop it down. This time period is when the most recent ice age occurred, so as such, you've got your classic ice age animals living at this time, such as your saber-toothed cats and your woolly mammoths and things like that. Could someone please bring the mammoth up onto the stage in front of our Quaternary clock? Could I get the volunteer to come up? Yeah, why don't you come on up? Yeah, we can go get her here. So grab the mammoth, and you're going to put it right in front here. Woolly mammoth, put it in front. That's a hairy elephant, that big one right there to your right. Yeah, that's the one. Just put it right up here, just right in front. Perfect. Awesome. Great job. Let's take a seat. Well done. I love that. Yeah, so, we got our name here on the time scale. This is also the time period when humans appeared. Us, antediluvian humans, Homo sapiens, showed up around 300,000 years ago, so relatively recently. And we lived most of our history as a species with these other ice age animals. Your woolly mammoths, your saber-toothed, they only died out around 11,000 years ago. So most of our Earth's history was spent interacting with these guys. And indeed, we do have evidence of this. There are plenty of mammoth skeletons that we found with cut and butcher marks from human tools and weapons. And on the opposite end of it, we were also hunted by saber-toothed cats. There's a human skull that I know in California that has a puncture hole at the top that matches up with the teeth of one of these saber-tooths. So we were directly part of the ecosystem back then, though unfortunately the rest of these guys are no longer around. We have the last vestiges of it. But anyway, let's continue on moving backwards in time here to the next period on our time scale. This is the Neogene. This time period here is a particularly important one. This is when Earth is starting to look more normal. The continents are in the same places basically as they are today, and then your modern mammals are starting to show up. Lots of your horses, your rhinos, your modern hoof mammals are really starting to spread apart. But you do have some animals that are cousins of things today that are a little bit different, such as our giant ground sloths. They originally hated this time. Someone can bring our giant ground sloth up onto the stage and put it from the Geologic. You there in the red hat, why don't you bring our ground sloth? Yeah, the cannon hat, absolutely. So the fun thing about ground sloths, these guys are 9 to 12 feet tall. So when I call them giant ground sloths, I mean it. They are absolutely huge. The sloths we have today, your slow tree climbing, you have the big, fluffy bear-looking one. This is what we're looking for. There we go. There's ground sloth. Yeah, put it right in front of the Neogene head. Sloths we have today, your small, tree climbing ones. Those are the only sloths to ever look like that. Oh, well done. Give a round of applause, everybody. The sloths we have today are the only ones to ever look like that. The giant ground sloth is the default sloth body plan. Most sloths are supposed to look something like these 9-foot tall behemoths. So again, we have living sloths today, but they're very different from the ones in the past. There are also some other really big things living around the Neogene. In the oceans, we have the megalodon, which you don't know was the largest shark to ever exist that we know of, ranging from around 50 to 80 feet long. These guys were swimming around the coastal, the coast of many of the oceans here during the Neogene. did dive into the Neogene though around 2.6 million years ago when the Ice Age occurred. When ice ages occur, sea level drops as it forms the ice. So the coastal waters that Megalodon needs to survive disappear, and they get stranded, and their prey disappears as well. So no Megalodon around with us today, unfortunately, or fortunately, I guess, depending on your perspective. But regardless, who knows? Give it a couple billion years, we might have another Megalodon as the sea levels rise, or a Megalodon to another giant shark. Let's continue moving on back to the Paleogene. The Paleogene is the first chunk of time we'll call the Cenozoic era, or age of mammals, which starts 66 million years ago and is still happening today, since mammals are still dominating the planet. This is when mammals really start to spread apart and start to take over the world. They were around before this, but they weren't really super dominant. But at this point, they're starting to appear. You got a lot of weird mammals that aren't around anymore, but you do have some mammals that we have today that are starting to make their appearance here. Mainly your first whales show up at this time. Can I get a volunteer to bring our whale up onto the stage? Why don't you there bring our whale up onto the stage? Absolutely. So whales, I just want to clarify that we know this. Whales are mammals. We know this, right? Whales are mammals, they're not fish. Mammals, typically, where do mammals usually live? On land, right? They don't live in the water, typically they live on land. And yeah, well done. Yeah, they live on land, right? But whales don't. Whales live in the water. Since whales are mammals, whales are descended from animals that used to live on land. And in the Paleogene, we see those first whales, and they still have legs. So the Paleogene is a time in which whales were still able to walk. They're kind of like furry crocodiles. They appeared in India and Pakistan. That's what they first originated, which at the time was an island. It wasn't connected to the rest of Asia yet. And if you know your geography, you know that between India and the rest of Asia lies the largest mountain range today, the Himalayas and Mount Everest. But because India hadn't collided with Asia yet, Mount Everest didn't exist. So during the Paleogene, you had whales walking on land that would eventually become Mount Everest, but it was flat at the time. So still starting to be familiar, but quite different in many ways that we're used to. Let's dial it back even more to the Cretaceous period here. This is the time period that you guys might be familiar with if you're here in Alberta. This is where most of our fossils come from, your classic dinosaurs and things like this time. But we got more than just dinosaurs. We've got pterosaurs or pterodactyls flying in the sky, cousins of dinosaurs, not the same thing. And we've got things swimming in the ocean such as your marine reptiles or mosasaurs. Can someone bring our mosasaur up on the stage? Why don't you bring our mosasaur up on the stage? Well, it's kind of like if a Komodo dragon wanted to become a shark really, really bad. So it looked like a bit of a lizard crossed with a shark right there. Absolutely. So these guys, not dinosaurs, but the largest lizards that ever exist. All right, done. Thank you very much. These guys, let's give them a round of applause, guys. Now, at this time, there was a seaway that split the continent in half of the western interior seaway. This is where a lot of your marine reptiles live. That's why we find a lot of ocean fossils here on Alberta, because we would have been right underneath the water at this time for most of that history. Now, this period ended with a particularly famous event. About 66 million years ago, a giant rock from outer space crashed into the planet, and that caused a mass extinction. That asteroid hit the planet so hard, it basically exploded, disintegrated, causing chunks of flying space rock to go across the planet. It's on fire, it's hitting all over the place, it's causing the forest to set on fire, massive forest fires around the planet. And not only that, but little bits of that asteroid dust are sticking in the atmosphere and causing, basically blocking the sun. So a few plants that survive those forest fires can no longer survive, they can no longer grow. So plants die, the animals eat the plants die, the animals eat the plants die, the animals eat those animals die. This is a whole ecosystem collapse here on a global scale. And all in all, about 76% of all life went extinct at the end of the Cretaceous period here, including all of your flying reptiles, all of your marine reptiles, and most of your dinosaurs, save for the birds, which we still have today. This is the most recent of what we call the Big Five mass extinctions. I'll cover them briefly as we go on through. And this isn't even the worst one. That's yet to come. So we'll learn about that in a little bit. But let's keep dialing the clock back to the Jurassic period. This is probably the one you're most familiar with by name. Ooh, wow. And the Jurassic is when your dinosaurs start getting really, really big and really start to spread across the planet. But it's not just, they're not just getting big. There are some dinosaurs that are getting really small, doing something very important. This is when your first birds begin to show up. Now, your first birds, the very different to the ones today. They still had long tails, they still had claws, they still had teeth in their mouths, but they're starting to get those feathery wings that are distinctive to birds today. So we're going to bring our first bird up on stage. Yep, you there in the black shirt with all the plants on it, or if that's Carl, I'm not sure. It's a very cool shirt either way. Come on and bring our first bird onto the stage. It's very different from the ones we have today, but you might be able to identify it. It doesn't have, it's got a long tail, it's got floofy feathers on there, it's got teeth in the mouth. There you go, there's our first bird. Put it right in the Jurassic here, there we go. Blue, absolutely. Now, we also had not just birds flying around, not just birds flying around here in the waters. You might hear the familiar croaking of frogs. Your first frogs appeared during the Jurassic as well. We didn't know things before this, but frogs, the modern frogs that know showed up in the Jurassic, along with your first flowering plants. Flowers didn't really exist. Most of them existed. It was very green in the past, but not with any other colors until your first flowers showed up. They initially appeared as water plants, so lilies and things like that is what your first flowers will look like. So in the Jurassic, you'd be showing up to a pond, you'd be able to see water lilies, frogs, and early birds. It look pretty similar to today on a small scale. All right, let's keep on trucking along to the Triassic here. The Triassic period is a very weird one, and I'm going to resist the urge to go on a tangent about it because there's a bunch of crazy stuff happening at this time. But basically, this is the start of what we call the Mesozoic era, or age of reptiles. It starts around 252 million years ago, it ends 66 million years ago when the asteroid strikes. So this is also commonly known as the age of dinosaurs as well. Dinosaurs first appear at this time, though they're very small, only about this big, and pretty rare. There were a bunch of other reptiles appearing at this time. Your first marine reptiles, your first pterosaurs, your first mammals show up too, but also your first crocodiles. And who wants to bring our first crocodile up onto the stage? Yep, why don't you bring our croc up? Yeah. So grab our croc. Now, crocs are very old animals. They show up at the same time as dinosaurs. You might have heard the phrase that crocs are living fossils, right? Yeah. You might have heard the phrase that crocs are living fossils. They haven't changed in 200 million years. That's not entirely true. The crocodile body plan, the swimming one with the flat snout that's fish grabbing teeth, that's been around as long as crocs have. But there have been a whole bunch of other crocs as well. In the Triassic, they reached their heyday with a bunch of crocodiles running. I mean, literally running around on land, hunting things like dinosaurs later would. You even had crocodiles that swam in the ocean, crocodiles that climbed on trees, crocodiles that burrowed, crocs that had beaks and ate plants. The Triassic was really the age of the crocodiles. They were the dominant animals. But at the end of the Triassic, there was a mass extinction. This happened when Pangea broke up. If you know Pangea, it's when all the land masses stuck together. When Pangea breaks apart, that's causing a lot of volcanoes to erupt, and that is bringing lava and ash and toxic volcanic gases into the atmosphere. That basically causes the climate to go like a seesaw. It's really, really hot, really, really cold. Really, really hot, really, really cold. Really, really hot, really, really cold. Back and forth, back and forth, back and forth, really, really fast, which is really, really difficult to get used to. So all in all, most of your big crocs that were dominating at the time died out, leaving the small fishy ones we know today. And your small dinosaurs and mammals and like early survived too. This extinction would wipe the slate clean for the dinosaurs to take over the world. So they weren't dominant before, but they became dominant in the Jurassic. All in all, between 75 and 80% of life died at the end of this period. All right, let's keep dialing back to the Permian period. The Permian is another one of my favorites, so again, I'm going to have to limit myself. But this is a particularly interesting time. This is the end of what we call the Paleozoic era, or age of ancient life. The stuff living at this time was very strange indeed. One of the classic animals of this time is this sailback Dimetrodon. And I would like to bring this one up on the stage. Who's not gone yet? Just want to go for people who haven't gone, so I can make sure turn. Yep, you there with the hat. You can come up and bring your Dimetrodon. Now, I love to do this with Dimetrodons. It's one of my favorite creatures. Can I get a show of hands? Who here thinks Dimetrodon's a dinosaur? If you do, that's fine. I'm not joking. I just want to know who thinks it's a dinosaur. You? Yeah, okay, fair. It's very much included in dinosaur books and movies and things like that. It's very common. Who of you guys think it's not a dinosaur, but it's another kind of reptile? A few more people. Yeah, fair point. How do you guys think it's a secret third thing? Yeah, well done. How do you guys think it's a secret third thing? Anyone think it's on something else? Yeah. Dimetrodon is not a dinosaur, it's not even a reptile, it's way older than dinosaurs. This guy is what's called a synapsid. And synapsids, like Dimetrodon, like the saber-toothed gorgonopsid, were the dominant creatures of the Permian. They were spread all across Pangea. They were kind of like the dinosaurs of their day, and the fact that they were the dominant creatures. So not related to dinosaurs. But kind of like the dinosaurs, almost all of them died out at the end of this period during a mass extinction. The only synapses to make it through, the only relatives of Dimetrodon to make it through, would eventually become us, the mammals. So Dimetrodon is closer to you and I than it is to a dinosaur or any other kind of reptile, which is pretty handy. Now I mentioned they died in a mass extinction. This mass extinction is known as the worst in Earth's history. It's the only one we've given an informal nickname. We call it the Great Dying. It's just, that's it, it's death all the time. And it's really difficult to explain this one because every time I learn it, like I read about it, I take a step back and look, oh wait, so another bad thing happened? It gets worse? Every time I learn about this, something new that's bad went wrong. Everything that could go wrong in this section did go wrong. So I'm going to try and really quickly try to sum it up. Okay, so big volcanoes burst their tops, right? Bringing in a bunch of volcanic gases and lava and ash spreading all over the place. Enough lava is released to spread across 2 million square kilometers. Really bad. Kills a lot of things. But also, this is releasing all that ash into the atmosphere, which blocks the sunlight so the plants can no longer grow. And all those toxic gases that are being released do a bunch of really, really nasty things. They mix it with the rainwater, cause acid rain, which is not good for anything. They also kind of mix in and make the air very difficult to breathe. They decay the ozone layer, which if you don't know is the shield that basically prevents us from getting radiation poisoning from the sun. So that's gone. Everyone's getting hit with radiation all the time. And all of these toxic gases are mixing in with the atmosphere and basically creating a super greenhouse effect. The global average temperature increased by about 10 degrees in only a few thousand years, which right now, scientists are freaking out about a 2-degree change being apocalyptic. So 10 degrees, this is the closest our planet has ever gone to becoming Mars. Dead, barren rock. All in all, 96% of all life on Earth went extinct at the end of the Permian. So everything that has survived since that extinction and is still around today, that is descended from the 4% that made it through. We would not be here had this not happened. The dinosaurs would not exist had this not happened. Had this not happened, the world would be completely unrecognizable, and I would not be doing this presentation. Instead, probably some sailback fellow would be talking about how this is a great time and nothing major happened at all. The point is, as insane and awful as this was, it paved the way for the modern world as we know it. So as terrifying as this, it's something that we kind of have to appreciate because we wouldn't be here talking about it. We wouldn't be here at all if it hadn't happened. All right, dialing it back to something a little less depressing, maybe a little more freaky, we got the Carboniferous period, also known as the age of the giant bugs. This is the time in which most of Earth's coal comes from. Most of the planet was covered in these massive coal swamps, or they would become coal later on. Massive swamps full of plants that over time they die, they stack up, they turn into coal. And in these swamps, you had giant bugs, such as big millipedes. Once we bring our millipede up onto the stage, you there in the back, yeah, once we bring our fuzzy little millipede on the stage, kind of looks like a black snake with a ton of little legs on it. This point in time, there was about 50% more oxygen in the atmosphere than there was today. Yeah, you got exactly another Carboniferous. Awesome job. All right, round of applause everybody. There's 50% more oxygen in the air than there is today. Our invertebrates, like bugs, they don't breathe like we do. They breathe through their bodies, through their exoskeletons. So they're not as efficient. So having more oxygen in the air means they can suck more rain directly, and they can get a lot bigger. So seeing this millipede, if you saw a millipede this size crawling around, you'd be pretty freaked out. This would be pretty big, right? This is small for the Carboniferous. This is Arthropleura, and it was 9 feet long. That's a surfboard-sized millipede. And in the skies, you had hawk-sized dragonflies like Megan right here. So if you're not a bug guy, don't recommend going back to the Carboniferous. Might be a little too creepy crawly for you. But if you like your amphibians, we had crocodile-sized ones, so that might be pretty cool. But otherwise, I might steer clear of the Carboniferous. All right, moving even further back, we've got the Devonian period. So this is known as the age of fish, because this one fish really diversify. Your modern fish appear at this time. Your sharks show up. Your ravenfish, which is like most fish we have today. If you think of fish, ravenfish. And we've got things like your lobefin fish, which include coelacanths and lungfish, but also one other kind of fish. There's a fish up here that looks kind of like a cross between a salamander and a crocodile. Who wants to bring that one up onto the stage? Who has not gone up yet? Again, I want to make sure that everyone who hasn't gone, at least tries to get a chance here. Yeah, why don't you come up? I know you've been very patient. Grab our green salamander-looking friend here. This is Tiktaalik. Tiktaalik is a very special kind of fish. It is a loathsome fish like coelacanths and lungfish today. All right, round of applause, everybody. Now, these guys, their fins are really weird because they are fleshy. And inside the flesh, they got bones. And the bones of Tiktaalik specifically, we're starting to see the first wrists and ankles. Which means these guys are the ancestors of what we call the tetrapods, which are basically any animal living today with 4 limbs and a backbone. Yeah, look, me, you guys, we're tetrapods. And trace our ancestry back to things like Tiktaalik. So these are all the relatives of the first fish to crawl onto land, which basically makes most of the diversity we see on land today. So we do owe lots of Tiktaalik. This period also ended with a mass extinction. This one is a weird one. I'm going to try to go through it very quickly. Basically, we think the trees did this one. I know, weird statement. But basically, trees breathe differently than we do, right? They breathe in carbon dioxide and breathe out oxygen. We do the opposite. Trees make the air we breathe. That's why they're so important. At this time, trees were brand new. They weren't really around before, so they show up. They grow everywhere they can really, really fast. And they do their job so well, they change the composition of the atmosphere. Because back then, there was a lot more carbon dioxide in the air. And they breathe that stuff in. Does anyone know what's carbon dioxide known for today? Anyone know what that stuff does? What's it mainly contribute to? Yeah?
It creates, it warms, it thickens the atmosphere and warms stuff up.
Yeah, it's mostly greenhouse gas. It contributes to the warming of the planet. So the planet during the voting was pretty toasty. But what's going to happen if trees show up and they start sucking out the global warming gas from the atmosphere? What's going to happen to the temperature? It's going to go down. It's going to get colder. So the trees did such a good job. They plunged the planet into an ice age. And they did that so fast that it caused sea levels to drop, habitat to disappear, oxygen to start being sucked out from the water for some reason. So a lot of the stuff that was living in the ocean at the time died out. About 76% or 75% of life died out at the end of the Devonian. Similar to the extinction that killed the dinosaurs in Siberia, but very different cause. So yeah, weird time. Time trees almost kill everything. But of course, we need them today. If we tackle the trees now, probably won't end too well for us. So we should keep them around now. But yeah, back then, they probably were the best for life. All right. Going back in time to an admittedly more relaxed time. So learning is a pretty chill time, all things considered. This is when your first freshwater fish are showing up, or sorry, the dry and freshwater fish. Largest fish at this time was about this big. Not huge, but respectable. You know, they're just getting started. The dominant creatures of underwater ecosystems were these things: your sea scorpions or eurypterids. Does anyone like to bring our sea scorpion up onto the stage? Why don't you and the orange bring our sea scorpion up on stage? Yeah, you bring a sea scorpion up on stage. Either way works. Now, funnily enough about sea scorpions, they are not scorpions, and they also didn't just live in the sea, they also lived in fresh water. So a bit of a misnomer on two fronts. Yeah, the blue one there. That's a pretty respectable size for a sea scorpion. Like, they got maximum about that size, but some of them, most of them are around that big as well. Yeah, there we go. So, oceans, pretty chill. On land, not a lot going on, but you did have your first land plants during the Silurian. This is Cooksonia. This is way bigger than Cooksonia would have been. Your largest plants in the Silurian, this big. Teeny, weeny, weeny. So, they weren't doing a whole lot. They were mainly just hanging out next to rivers and stuff. There wasn't a lot of soil yet, so they get super big. But this is very much a humble beginnings type scenario, right? They're starting off small and not a lot of places, but over time, they were able to adapt and spread to the point in which they caused a mass extinction for the So, this is like this. They're not huge, but this is when they start. I think it's important to acknowledge, where they're starting from. All right, dialing it back to your vision. Again, another one that I gotta prevent going on a too long of a tangent about. This is a very strange time period indeed. I'm going to focus on the oceans first, because in the oceans, place looking a little bit weird. You've got your fish at this time, sure, but they were about this big, and they didn't have any jaws yet. So instead of having a mouth that they could open and close, like I'm doing as I'm talking to you, their mouth was perpetually stuck open, so that every single fish at the time looked like they were just in a state of shock. Just swimming around like that, they just swim into their food and swallow it. But you know what? Look where they ended up now. I think we gotta respect, where they started from and how they ended up. The dominant creatures of this time would have been your giant cousins of the squid and octopus. These are called cone-shelled nautiloids, kind of like a squid stuck in an ice cream cone. Who wants to bring that one on stage? Any takers? Anybody? Have you gone up yet? Oh, we want to make sure we have like, you get a chance to go at least once. You there in the red hat and blue shirt? Yep. Come on up, grab our ice cream cone squid, absolutely. Large, these guys got to about 20 feet long, so about the length of the stage, so pretty big. We also had your first sea stars appearing at this time, and your first coral appearing at this time as well. Yeah, put it right on down there. All right, round of applause, everybody. That's in the ocean. On land, it's dead. There's nothing there yet. It's a dusty rock. There's no flies, there's no worms, there is not even a lick of moss on the land yet. It is a barren rock. And because there's no plants on land yet, that means that if you went back in time to this point, it'd be like trying to breathe like on Mount Everest, but you're at sea level. Because there was half as much oxygen in the atmosphere back then than there is today, so it'd be very difficult to breathe. The days were shorter back then, about 21 hours long, because the moon's a lot closer, and the moon's gravitational pull affects how fast the Earth spins. The moon's slowly spiraling away from us over time. It's days longer over time. Don't worry, it's not going to happen in our lifetime. 300 million years, well, 26-hour-long days. And if you stuck around at night, you might notice a faint line going across the horizon, because there was mounting evidence that during the Ordovician, Earth had a ring around it, like Saturn does today, which is wild to think about. That'd be quite the night of stargazing, I think. All right, this also ended with the Earth's first mass extinction. We don't know as much about this one since it's so far back, but we do know things got really, really, really cold really, really fast. When ice ages happen, right? Ice forms, sea level drop, oxygen decreases, habitat gets lost, things suffocate. So all in all, about 86% of life died out at the end of this mass extinction, so it was the second most severe, but we still have a lot more to learn about since it's so far back. Speaking of going far back, we've got a couple more years to go. We've got the Cambrian period. This is the first period of the Paleozoic era, which the engineers and life said, but it's also the first period of the Phanerozoic eon. The Phanerozoic eon is the big chunk of time that these eras belong to. It basically means the age of life, for I think very obvious reasons. This is when a lot of our diversity of life begins to show up. And this is when your first hard bodies animal appear in a lot of your modern groups of animals. For example, we've got these guys on the top left. These are, oh, actually, I have laser. These guys, these are trilobites. Trilobites are like little pill bug, will mouse-like guys. They swum around the oceans for about 300 million years. They did very good for themselves. And they were hunted by this guy, Anomalocarius, aka the weird shrimp. Once we bring our weird shrimp up onto the stage, you're there in the orange and the red. You've been very patient. Come on up and bring our weird shrimp onto the stage. These guys were, just remember, they're the first apex predators. They were also hunting things like Kaya right here. Kaya, this weird slug-looking fella, is an ancestor to everything with a backbone today. Yeah, the weird shrimp looking right to your, yeah, there you go. Go right on down there. Awesome work. All right. So, Kaya, first ancestor of things with a backbone, so everything that exists today was fine. We can thank Kaya for it. This is a time in which, yeah, a lot of animal life as we know it appears. A bunch of stuff that survives today, a bunch of stuff that didn't. So it's very important understanding our origins as animals. But we got one more thing to talk about. The giant red block of time in the room. This is the Precambrian super eon, which as you can tell is a very, very long time. This takes place about over 90% of Earth's history. It begins when the Earth forms 4.6 million years ago and ends around 540 million years ago. As you can tell, we don't have enough room to fit it on the stage. So I'm going to need some help to illustrate how much time this is. I need one volunteer to come up here and help me out. You there in the unicorn shirt, come on up. All right, I'm going to need help with this. So I want you to come up, see this. I want you to take this, and I want you to walk that way until I tell you to stop, okay? Go. Oh, hold on. Uh-oh. Looks like we're jammed. You want to put it down? I'll just tell you to keep walking. So go. Keep walking, keep walking, keep walking, keep walking, keep walking. Keep on walking, keep on walking. All right, go through the door and turn right. Yep. Turn right that way. Keep on going to the other door. Thanks. You can close it. Keep going, 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 keep running, keep walking, keep going, let's go, keep going. We're doing great. Keep going, keep going. Open the door. I think it's a pull. There you go. And keep going, 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 keep going. Stop. You are where Earth starts 4.6 billion years ago. And we start from there, going all the way around. Yeah. We start there, go all the way around to here to 540 million years ago. That is how much time pre-Cambrian takes on our time scale. If you just stay there for 1 second longer to illustrate this, our first ever life on our planet shows up around right about here by your sandal. This is one of the earliest fossils we have. This is a stromatolite. It's a bacterial mat, and these guys show up 3 billion years ago. So about 1.6 billion years into the timeline is when these guys show up. And the craziest thing about them, you might be wondering, why do we know this is a fossil? This looks like a squiggly rock. And that's fair. That's fair. This does look like a squiggly rock. How do we know it's a fossil? Yeah, it's a fossil. How do we know this is a fossil? Well, here's the crazy part. These 3 billion-year-old stromatolites, we still have living ones today. We have living members of this group still on our planet. So we can directly look at the living things, look at the fossils, and be like, it's the same thing. The first ever life on our planet, representatives of that group are still living with us today. And I think that speaks to this, the absolute ridiculous resilience of life on Earth. Because not only do you have these things that remain pretty similar for billions of years, but also you've got all this insane diversity of life that's gone through so much, all these different trials and tribulations, these extinctions, these diversifications. I think it really just shows how much life can handle and how much it can change. So no matter what happens in the future, life's still going to be around, but I'm so curious to see what crazy forms it takes next. So thank you guys so much for bearing with me. That was a big ramble. Thanks so much for coming.